In this video, we're going to look at how to find the inverse of a 2 by 2 matrix. So we're going to start off by saying let matrix A equal this matrix with entries A, B, C, and D. Just doing this in the abstract so I can give you a formula for this. A inverse, which is denoted by this little -1, which looks like an exponent, that's just our notation for the inverse of matrix A, is equal to 1 divided by the determinant of A multiplied by this new matrix where you take the two entries A and D here that are on what we call the main diagonal, and we switch them. So this entry comes down to here, and this entry goes up to there. So looking here, the A and the D have just switched places. And then on the other diagonal, we didn't move the entries around, but we changed the signs. We made them the opposite of what they were originally. So to do this, we have to first find the determinant, and that will create this scalar out here of 1 over the determinant of A. And then we will need to multiply that scalar times this new matrix where I've switched some entries on the diagonal and changed the signs of some pieces. Again, we've looked at how to find determinants of 2 by 2 matrices in previous lessons. We've looked at how to do scalar multiplication in previous lessons. So this is just kind of bringing it all together. Let's look at an example here in a second. Looking at this example where matrix A is this 2 by 2 matrix, entries in the first row of -3, 6, and in the second row of -3, 1, we want to go ahead and find the inverse of this matrix. So the first thing I'm going to do is I'm going to find the determinant of that matrix. So if we remember from previous lessons, the determinant of A, the determinant of a 2 by 2 matrix, is the product of the entries on this diagonal. So -3 times 3, which is -9, and then minus the product of the entries on the other diagonal. -1 times 6 is -6, so minus -6. Simplifying that, I have -9, that becomes +6. So the determinant of that 2 by 2 matrix here is -3. So now, to find A inverse, we do 1 divided by the determinant times this new matrix where I switch the entries on this diagonal. So this -3 will come down to here, and this 3 will go up to there. And these numbers on the other diagonal just change sign. So instead of 6, this becomes -6. Instead of -1, this becomes +1. And now I actually need to do this scalar multiplication. So I need to take this fraction, this -1/3, and multiply it in to each of these entries. -1/3 times 3, that would be 3 over -3. -1/3 times -6 is -6 over -3. -1/3 times 1 is 1 over -3. And -1/3 times -3 is -3 over -3. Again, just writing those like fractions. And now I'm going to simplify each of those. So this first one, 3 divided by -3 would be -1. -6 divided by -3 would be +2. This one here would just be -1/3. And this one here, -3 divided by -3 is +1. So here we found the inverse of matrix A to be this matrix containing entries -1 and 2 in the first row and -1/3 and 1 in the second row. If you're entering these into our EdgeElastic system that we're using to put these answers in, anytime you get the fraction like this, make sure you're putting it in as a simplified fraction, whether that's an improper fraction or not. And also, if there's a negative in it, let's put that negative with the numerator. When I use the feature to set these problems up, your answer, if it's not put in that format, it's not going to recognize it as equivalent. So I would just put in -1, use the slash on the keyboard for my division bar, and then 3, since I can't use the fancy equation editor feature in this type of question on that platform.